Let's get started for today. So let's see, I want to start off with the poll I did and a couple of comments about that. I did this poll. Here are the results. Hopefully you guys remember it. At least 18 of you answered. So I was looking for some feedback on the material because what we're about to do now, we're really kind of going to ramp up a little bit. And so I wanted to know where you guys all thought you stood. And as a result of this, I kind of modified our schedule a little bit. So let me elaborate on that for just a second. So I asked this question of, tell me where you are with Simio. I'm comfortable with the material, let's go. Sort of following along. Take me quite a bit of time to get comfortable, but go on slowly. Those are the only 2 responses I got. So I got 7 responses on I'm comfortable, let's go. 11 responses on it's taken me quite a while, so go slowly. So what I decided to do, and I'm really glad I got none of these 2. This would have been a little bit problematic, but I didn't, so that's good. Hopefully you guys were all honest. But what I decided to do was just slow down just a little bit. And in particular, what I decided to do was we have here assignment case study number 3. In case you haven't seen it, it's up there. And my planned schedule was to basically just assign case study number 3 and then move on to the isomatic 5 templates and all. But I decided not to do that, and so I decided instead that what I was going to do was talk about case study number 3 this whole week. So in class today, I'm going to talk about planning and implementing for case study 3, and in the video module, I implement the base case study 3 just totally step by step. And so the first part, if you've looked at, hopefully some of you have looked at case study 3 since I put an announcement saying please look at it. The first part is just replicate what I do and run a couple of sample files, and then I'll have some more to it when we get back from spring break. So that's our poll. And I will just say in the context of that poll, I haven't gotten a huge amount of feedback from any of you guys about pace of the course and all that other than this poll. So I get questions periodically either by email or in the discussion forums, but really nothing in sort of a general satisfied with the pace, go faster, go slower, I'm lost, it's boring, or whatever. So that would really be helpful for me. So you might see another poll coming up. So let's see, there were 2 things I wanted to mention before I open it up for questions. I didn't really get any questions this week, but based on what I have seen on Canvas, I wanted to mention just a couple of things about the plan view, because I've seen quite a few people who have problems in the plan view, in particular with the user interface. Okay, and so remember with the plan view, I don't have my mouse out, I need my mouse. I will just tell you that the user interface for the plan view has a lot of moving parts. And certain things you can do and can't do and all of that. The easiest things that you can do is you can zoom. And so when I ask for you guys to turn something in, what I usually want you to do is zoom to all so you can just see everything. And then, copy that. But when we get to the point where we're looking at the plan and trying to make decisions based on what we see in the plan, then we need to be able to do things like zoom in. And so you can zoom in, if you have your mouse wheel, you can zoom in here. You can pan, but you have to have your mouse up here in order to pan. And so there is an extensive help. If you look up help and look up resource plan, there's an extensive amount of how to interact with it. Okay, and that's really important because, as I said, there's a lot of things you can do. Another thing that I've seen people do a couple times is if you try to pan and you're in the body of it, you can insert what's called a stipulation. So let's say that I want to pan here, and I just happen to be right here, and I drag that over there. What I just created was what's called a stipulation, and you can see that here. And that stipulation is basically saying, hey, the user wants this task to come before this task. Okay? And so now, even if I go back and replan, that task is still there because you've created a constraint saying, I want this here. Okay? So if you see this, and here's the constraint I just put in, you don't want that. We'll talk about stipulations a little bit later on. We don't want that for anything that we're doing right now. Yes, sir?
Shouldn't there be a button somewhere that you have to press before you can do that?
I'm not a user interface designer, so I'm not going to comment on that. But once again, I will say there are a lot of moving parts to this. When we haven't talked about them in detail, There are so many things you can do with mouse hover, mouse clicks, mouse click, mouse drag, the wheel, and all of that stuff. And so look in the help, and it will explain all of that. But the critical things for what we're doing right now is recognize that you don't want to create stipulations. If you want to pan, you can do it by just putting the mouse up here. If you have a touchpad, you can spread like this, and it will zoom and contract and all that kind of stuff, equivalent to what you do with the mouse. Okay, but if you ever see anything in the stipulations window, you want to get rid of it. Yep.
How do you get rid of it?
Okay, so if I have a stipulation,
Button.
like right here, right? I just created one. There's a delete all button.
And that gets rid of all of it?
Yeah. So if you here's the stipulation right here. Maybe I have another stipulation right here. So now I have two different stipulations. If I delete all, it's gone, but the window's still there. You can close the window by just clicking right there. That will close the window. Okay. That's the first part. The second thing I want to talk about is for case study 2, we had 2 different order files. Okay, and I was not clear on how to do this. I'm sorry, I apologize for that. But I got quite a few questions that led me to believe people were trying to have multiple tables in the same file or creating multiple files. Both of those are not what you want to do. Right? You simply want to either change the file name in the binding and rerun it, or create multiple bindings where you can, have 2 bindings at once and make one binding active. Okay, but not have multiple tables in the same thing. And the use case for this is like if you have a planning system, if you wanted to use this for scheduling, for example, that orders file is what you would get periodically, like every week or every day or every month. Right? And so you want to have your system configured so it reads that file in with the latest data. Okay? What you're going to see in case study 3 is that we have 2 files that consist of a scenario. So we're going to build a model. We'll talk about it in a little bit. And you have a source file, you have an orders file, you have a materials file. And those 2 files are what we're calling a scenario. And so the easiest way to implement scenarios is to have multiple bindings. So I can create multiple bindings and attach the files to a scenario, to a particular binding, and update all the files in the binding. Okay, well, we'll see that here, not today, but later on. But just kind of keep that in mind as we go forward. So those are the 2 things I wanted to mention that I'd seen in other stuff. And so one more thing, and then I'll open it up for questions. Looking at our schedule here we are, day 2, however many 2s there are today. We're going to talk today about case study 3, video case study 3. Next week we have an exam on Tuesday. Remember, 75 minutes in here for the on-campus section. There's no video module. Then you have spring break. Then we get back, and case study 3 is due on this Friday. Okay? So depending on what I hear from you, we can change that. We can shift that. I can allocate some time in this week to go over that. But what I need to hear from you is, do you need me to do that? Because I don't want to allocate class time to discuss something that you guys all know. By the same token, if people are having problems, I want to allocate time to discuss it. Okay, I don't want to just answer everybody's questions off individually because that doesn't contribute to the rest of the class learning. And really, what I need to hear from you is what you find easy and what you find hard. Because as I said, this case study 3 kind of steps up a notch of what we've done so far. So with that, does anybody have any questions for me before I go on? Yeah.
Will you go over, I know you've gone over it before, but will you go over again what the content on the test is going to be like?
The content on the test is going to be all short answer. And so my target, I have not done the test yet, some thoughts on it. I would like to have 5 10-point questions and 10 5-point questions. That's what my target is. And the questions will all, as I said, will all be short answer. So I will ask you concept questions, not specific code questions. But, be a little careful because sometimes you might consider something a code question that I don't. So if I say, what's the task sequence? To me, that's not a code question. It might be a code question, but it will be questions like that. Just things we've discussed in class.
So we should review both the PowerPoints and the concepts that you show in the video module.
Oh yeah, and all the video modules and everything where we talk about concepts and we talk about again, I try not to ask specific detailed implementation things, But there are concepts that we go over in the video modules and in the models that you implement that I want you to understand those concepts. Okay? I mean, I know that's kind of vague. You know, if you can think of a question, ask me the question and I'll tell you, yeah, that'd be fair game, or no, that wouldn't be fair game. You know, I don't know how to be a little more explicit than I'm sorry about that.
Can we make a discussion for the test?
Sure.
Where we can put those questions like.
Yeah. Yeah. Okay. And again, let me just make one more comment about test. It's testing in general, right? My strategy for testing is to be as vague as possible because my goal is for you to study everything because I want you to learn everything. I obviously can't ask you everything in 75 minutes. I don't want to narrow it down too much because then you'll just study what I tell you, right? The whole goal is not just to test you and get a numerical score. It's to get you to study to learn all the material. Okay, so keep that in mind. Any other questions for me before you start for today?
Have the case studies been looked at yet? Like, general, were they good or bad?
The first one's been graded and released.
Yeah,
the second one, Grant, where are we on the second one?
I downloaded the zip file and I looked at a couple of them, but not enough to have something that I would want to say in class.
Based on the questions that I've gotten, I would assume that they're reasonable because I have not gotten a huge number of questions like, oh my God, I can't do this, or that's, you know. So my guess is that they're reasonable, but hopefully we'll know relatively soon.
But it was a subsection. So.
I will say that some of the questions I've gotten lately lead me to believe that at least some of you are behind. Like I'm getting questions about video module 4. The stuff we're doing now includes all the video modules. So you need to get all the way through video module 5 before you're going to understand stuff that's going on for what we're doing this week. So again, that goes back to it's a new class. I don't know the right pace to go. Give me feedback and I will adjust to what we need to do. I'm happy to adjust. I'm happy to go over topics, whatever, but you have to tell me. Okay?
I think in terms of speed, like being able to get through the content faster, like I know you've said that you want us to make some of the Excel things. I think it would be, like I could get through the videos faster if I had those Excel sheets, because then I wouldn't have to type in order and then the date and all of that, and I could build the like example model faster and then have more time to play with it rather than spending time typing out the Excel thing with the video paused and then going back to the video.
Yeah, and we're going to do that starting after this one. Okay. So this one, I want you to do it because once I give you the CSV file, the structure is all defined. And defining the structure is the hardest part, right? And so for the things that are really straightforward, I will give you the CSV files going forward after this one. This one I decided to do from scratch just because I got the feeling that it would be helpful. But hopefully this is the last one. Okay, so what I'm going to talk about,
I have a question for binding and copy.
Okay.
Binding for, so when we have, for example, we talk about this on video, sound, but for example, if we have every day or frequently changing plan, so is it good to bind the table? For example, if we bind the table, then we work later on and the table behind is updated, so it will be automatically imported in the.
So when you bind a table in Simio, you have the thing that you want to pay attention to is.
Can we use copy, for example, every time you need to do this? This is for sure, but.
Well, I mean, when you copy from Excel, that's totally different than binding. Binding and copying from Excel are totally different. When I bind it, it's bound to that file. And the binding has an option for, you've got the two ones that we focus on are automatic and manual. If you have the binding set to automatic, every time you run the simulation, it goes out and reads the data in.
And so when the data table is updated?
It doesn't matter whether it's updated or not. When you click run, it goes and gets it.
So do you suggest us, for example, in the future, when we have frequently changing tables, binding?
Think of what I'm saying.
Okay.
When you click go, it goes and gets it. If you do manual, then you have to click on the import table. Okay. So what you want is to decide, when do I want it to read it in? If I'm running a scheduling system and I get a new schedule every day and I run this schedule every day, I probably want the binding to be automatic. If I'm debugging my model, I don't want it to be automatic because I want to know when it's going to change that update. So, that's kind of the general strategy that you want to use. But copying and pasting from Excel is totally different than binding. You're just pasting it in. It'd be just like me typing. It's just a lot faster.
But when contents are there, we are working the same way, right?
Yeah. Yes, sir.
So the way that data tables are constructed in Simio resembles a lot the way relational databases are constructed. So what if we have a non-relational database, a document-based database? Is there a way to have data-driven Simio models from non-relational databases? Plugins or any tools like that?
Not really. I mean, the relational data, if what you mean is rectangular data, is set up to handle rectangular data of fixed types, all of the Simio types it supports.
Okay.
And you can have primary key, foreign key, but it doesn't have referential integrity checks or any of that kind of database stuff, right? You have the column key and foreign key is important to us, but it's important from a Simio internal standpoint. And we're going to talk about that very thing here with this model too. But there's no non-rectangular database that I know of to do the model. Anything else?
Do you have any cases where in an order we have more than one part?
Yeah.
Or
We haven't done any of that yet.
Yeah.
We will, but we haven't.
one part?
Okay.
Yeah. One part type.
Yeah.
Okay, so what I'm going to do today is I'm going to talk about planning, design, implementation, methodology. Okay, and so I use, when I develop models, I have a very general development methodology that I use. There are other methodologies, but this is what I use. And so I'm going to talk about this a little bit and then kind of go through this process. So I start out with something called a domain model. And a domain model really is the scope and objectives of the modeling project. And typically, this domain model is developed with the stakeholders. So I'm doing a project for a company. I'm working with the company to figure out what they're trying to do. So the model that we're doing for case study 3 is Albi Electronics, the global electronic manufacturers. But our focus for this project is developing a scheduling model for a specific production line and a specific plant. And so that's scoping the project and then developing a set of objectives. And that's what we call the domain model. From the domain model, we do develop something called a conceptual model. And so we talk about this as in conceptual design, right? And a conceptual model is a language-independent description of the model to be developed. In other words, someone who knows simulation but doesn't know Simio, maybe they know AnyLogic, Arena, ProModel, AutoMod, Simulate, should understand exactly what you're talking about in the conceptual model, because that's what I mean by this language-independent. It's taking the domain and saying, how am I going to simulate? What is my basic strategy going to be for doing the simulation? Of course, there's feedback here. How you go back and forth. It's not a linear path. Then there's something called an implementation plan. And now we're starting to think about, from the conceptual model, how am I going to do this in the language that I choose? Okay, again, it's not linear. And the exact structure of this plan really depends on who's doing everything. So if you individually are doing it, if you have a big team, a small team, all of those things are going to go to what this exactly looks like. Okay? But it doesn't, as I said, doesn't have to be formal. It doesn't have to be a start to finish. Here's the beginning of the model. Here's the end of the model, as you're going to see, because I'm about to do this or talk about this in the context of this model. And then finally, you have the Simio models, because again, or whatever language you're doing. And this is the set of models that implement the conceptual model to meet all the objectives in the domain model. Okay, so it's a typical modeling methodology that I follow. And how you implement this depends on who's doing, what the team size is. So a lot of times when I do either consulting projects or big projects, it's me working with a junior engineer. So the typical working that we would do is I would work on the domain model with the stakeholders. Then the junior engineer and I would get together and work on a conceptual model implementation plan together. And then the junior engineer would take and go do the Simio model. So that's kind of a typical way. And then there's, of course, as I said, the feedback loops there. Okay. On the implementation plan, as I have parenthetically there, that you want to have this written. Okay, you want to have this written down. You don't want to try to remember this. Okay, and so I could show you that, the notes that I have from developing this case study, probably 10 pages of handwritten notes about how to implement and all that kind of stuff. Right, and so that's an important thing that you want to do. Okay, so I'm going to do this. What I'm going to talk about today focus pretty much on just a portion of the implementation plan. I'm going to talk a little bit about the conceptual model, but primarily focus on the implementation plan to give you some idea of what this is. But keep in mind that what I'm doing here is I've already done this. I've already done the project, right? So you're not getting a snapshot of someone handing me, a project and me doing the conceptual design and implementation plan from scratch. What you're getting is a view of me trying to explain to you how I would do that after I have already done it, at the same time trying to design the case study. So trying to kind of simulate this process, but I'm coming at it from a different knowledge base than I would if it was a real project. Okay, so let's take a quick look at the case study here. So I have it here. I'm not going to read it to you. Hopefully you guys read it. No big deal if you didn't. You can catch up. So what we have here is a manufacturing system, a flexible flow line, 4 stages. You have kit, assemble, finish, package. 2 of those work centers have multiple stations in parallel. So all of the components, there are 3 different component types, Module A, Module B, Module C. And then I describe these individual stations. So the kitting module, in the kit station, the components are retrieved from storage and placed in a tote along with the boards and housings. So all of these 3 modules, Module A, Module B, Module C, are electronic modules that have a board, components, and a housing. And the difference between A, B, and C is the different components that go on the board. Housings and the boards are commodities, so we're not tracking those at all. We don't care about those. And so they put those all in a tote. So it's a kit, and it goes to the next station, which is assemble. When the kit arrives at the assembly station, the components are then individually, assembled onto the board, placed in the housing, boards placed in the housing, and then they go back in the tote. They then go to finish. At the finish stage, the modules are removed, placed in a dedicated fixture, painted a given color. We have 4 colors, red, green, blue, and yellow. Once the paint dries, the modules are removed from the fixture and placed back in the tote. And finish, as I said, has 3 parallel stations. Packaging, they're placed, removed from the tote, placed in individual boxes. Boxes are specific to module types, placed in a shipping box, and they're ready for shipping, and you're done. So that's the basic process. The company is interested in using this model as a scheduling tool and is also interested in things like our typical things that we've seen, order fill rate, make span for a batch of orders, station utilizations, material shortages, kind of typical things that we've seen before. We're going to make several assumptions here initially. Each station has its own dedicated operator, except for the sequence-dependent changeovers at the paint station. So if you go from red to green, you have a sequence-dependent changeover. Everything else, operators are dedicated. Stations and work center are identical and can be sent to any station. For the first case, we're going to ignore work schedules and assume that Avi Electronics works 24/7 with no work stoppages, no lunch, no breaks, no nothing. All modules in the same order are the same type and color, to your question for this one. So if you have an order of Module A that are red, every one of them in that order, Module A and red. And then I say some of these are not realistic and not worker-friendly. We'll revisit some of these a little bit later on, maybe in case study 4. And I give you a bunch of data. Okay, so the operation. So in each one of these stations, the operations are divided into setup, processing, and finish. Let's give you all the times for all the modules in all the stations. And note that the setup time and finish time are per batch, whereas the processing time is per module. So if I have an order for 10 modules, at kitting, there's a 15-minute setup, there's a 10 times 10 or 100-minute processing, and then there's a 10-minute finish. Okay, so I give you all that data. I give you the sequence-dependent changeover data here. Note that there's an operator required to do that. Give you all that data. And then the bill of materials. So we have at different stages. The kit tells you the components. So a module A has 1 component A, 2 component Bs, and 4 component Cs. When it gets to the finish, it has some paint. The paint has an asterisk because the paint can be one of 4 colors. There are 4 colors of paint: green, red, blue, yellow. Right? So I just say paint there, but it's going to depend on the order as to which specific paint you need. And then in packaging, you have a box. Okay? Orders are, you've got the following information. I won't read all that to you, and I've given you sort of an overview of, this is a picture of my Excel file with some order data for your information. And let's see, what else did I give you? We have a module inventory. Okay, so we have a module inventory. I mentioned to you that you have scenarios to run. So a scenario consists of an order file and a module inventory file. And you read both of those in, and that's what a scenario is. Okay, let's see. And again, the assignment, the first thing is to just replicate this. I give you 3 different scenarios. I want you to run those and give me the usual information. And then TBD, I'm working on something else that I will have ready for you sometime in the middle of spring break. Whether you work on a spring break, it doesn't matter. There's plenty of time if you don't work on a spring break, but I'm not finished with that, but I will put it out. Okay, so that's the basic assignment.
So for the chain over table, what you're saying is like it's IJ, like if
A changeover table, right, it's IJ. If I go from red,
so
right.
If
Yeah.
the first, the previous batch was I,
Yeah.
and I need, okay.
Yeah, so if I'm going from green to red, it's 120 minutes. If I'm going from green to blue, it's 75. From red to green, it's 240. So it's just a from to. Okay? Okay, so what I want to do is now you have this assignment or you have this problem. I want to talk about this conceptual design, the process that we would follow. Domain model, again, as I said, is done with, is done typically with the stakeholders. Okay, now, Obby Electronics, we don't know anything about. Actually, I made it up for this class. There is no Obby Electronics, so there's no stakeholders to talk to. So domain model, in most class assignments, this is given to you. It is not something you do. In the real world, when you do a project, this is a critical thing because the domain model kind of establishes pricing and time estimates and all of that. In a class environment, that's practically always given to you. We have some objectives here. As I said, if you look at the assignment, I have a couple things highlighted. We want to use it for scheduling. And there's some specific metrics that we've highlighted there. So domain model, really kind of simple. Conceptual model, as I said, is this language independent. And so here's where we start thinking about applying simulation knowledge, but not specific to Simio. So in this case, what we want to do is we want to simulate orders. And so we want to process orders through our system. And we want to enforce material constraints and capacity constraints and things like that. And we want to track a whole bunch of information as we do that. Okay, so again, pretty straightforward from a simulation standpoint. And then we go through, yeah.
So I have a question that's kind of not related.
Okay.
If you have, like that table you just showed, the order is in the second column, and you have said you traditionally like to do it in the first column. If I built my Simio table with the order ID in the first column, could I still bind that table?
I don't know the answer to that. I believe that if you have headers and your headers match, that Simio will figure that out. It used to not. It used to be very specific to columns, but I think it will find those. And I think you can skip columns and all of that now, but don't hold me to that. I don't know for sure. Okay, so then we start going still in the conceptual modeling stage to let's add some again, language independent details like modules define a process sequence, including operation time, secondary resources, material requirements. An order is a batch of modules, all the same type and color. It arrives at a specific time, has a specific batch size. We want to simulate orders as model entities. They arrive at a specific time. They follow the sequence, the stuff that I mentioned before. We want to process a given set of orders, for example, for a week or a month or whatever you happen to be given. And the orders, when we process those, we want to record completion time, lateness, utilizations, material constraints, make span for the order. All of that was kind of given to us. And then we want to use the completed model as a scheduling and planning tool. And we have at our disposal resource plan, entity GAN, dashboards, logs, all of that kind of stuff. Okay, so this conceptual model is saying, I'm going to take the domain and I'm just kind of narrow it down. Okay, and at this stage, I would be satisfied with this conceptual model. In other words, we could add more detail, but really, it's really a pretty straightforward process from a concept standpoint. Okay, so now we move to the implementation plan where I'm really going to spend the rest of our class time. And what a written plan says, I'm transitioning from my conceptual model to a specific model, Simio, okay, in our case. And so, as I said, this is something that you want to write down. Okay, this is not something that you open Simio and start just typing away. Right? This is written, okay? And again, the implementation really really depends on the team doing the project. For this particular one, the first thing that I think about from an implementation perspective is I want a data-generated, data-driven model. I know that. I have a whole bunch of standard stuff, and I'm sure what you're thinking, at least what I hope you guys have been thinking as we were introducing this problem, is, hey, we have a whole bunch of standard stuff. We have a source object that we're going to use to create orders from an order table. We're going to use some kind of server-based objects, probably subclass them to do for the processing stations. We're going to use task sequences because we have this setup, processing time, finish. We have materials. We're going to use interactive logging. We have some secondary resources, right? So as you're doing this interactive, I hope you guys are all thinking that. Okay, now, the absolute worst thing you can do now in this process is say, hey, that's sort of like case study 2. Let me go grab that model, open it up, save it under a different name, and start going from there. It's a terrible strategy, terrible strategy. But people want to do it. I want to do it all the time. Believe me, I want to do it myself. And you're fighting yourself all the time to not do that. With this one, there's some relatively new things, or new to what we've done in this class. And so I've sort of picked out some of the new things that I want to talk about a little bit. One of them is I want to use material elements for a module and for raw materials. And so we haven't seen this, but I talked about this. And so if you go back to case study 2, again, and look at how we define parts, we define parts with a part table and a sequence table, and our parts were defined as strings. And I said earlier, a couple of weeks ago, one of our objectives now is going to be to replace that with materials. Right? So we're going to have the same concept where you have these unique identifiers, but instead of a string, I'm going to define it with a material so that I can use replenishment and all of that stuff that comes along with materials. Right, so I know I want to do that. The second thing, sequence-dependent setups with a dedicated operator. Okay, now, if you have never seen sequence-dependent setups in Simio, the key here at this point in the planning process is to stop, open Simio, go to the help, say setup, and just look at what it gives you. And about the 5th one down is a symbit for doing sequence-dependent setups. Right? So look at the symbit, look at the help, look at whatever, but you're trying to, again, get an idea of how it works, right? Because we're transitioning from conceptual to implementation, and you're saying, you've got to say to yourself, how does this work in Simio? Okay, and so go to Simio, look at the help, look at the symbit, get an idea of how that works. Because again, we knew it existed, but again, relative to this class anyway, we haven't seen it. Okay, so you need to have some idea of how that works. Then we have this notion of work centers and stations, which I'm going to talk about, and this notion of bill of materials and material consumption, which you haven't really seen a whole lot. I'm going to talk a little bit about that. So I'm going to talk about those two things quite a bit. And then the last thing I'm going to talk about is laying out the table structure. Okay, and so at this point, again, we're all on paper. The only thing we've opened Simio for is to look at that symbit or look at the help and get an idea of how sequence-dependent setups work. Okay, but we're still on paper. Okay? So what I want to focus on, these 3 things. I'm going to try to use this so that I can save it. I'm terrible at using this thing, so it might not work out, but I'm going to give it a try. Okay, so anyone have any questions before I go on? Okay, so we think about this. The first thing I want to look at is this concept of stations here. Right? So go back to the scan, and you can see that I have, I have what I'm calling work centers and stations, and work centers can have multiple parallel stations. Okay, and that's my concept. But now I have to transition towards, well, how am I going to do this, right, in Simio? And again, we don't open Simio and start plopping stuff down. We're thinking about how we want to do that. Okay, and so what I'm thinking about is something that I want to do. It's kind of like this. If you look at what we have, I'll just put these 2 here. So we have a symbol. We had 2 of those. And we have paint or finish, I think I called it. We have 3 of these. Right? And I have stuff that comes in here, goes between those and goes back. Right? And I know what I want to happen is when I come out of a symbol and go to finish, how does that happen? Like, how do I make that transition? And if I'm thinking about like task sequences, for example, where I go from kit to assemble to finish, how do you make that work when you're going from mini to mini in this case? Right? So you're trying to think about how to plan that. One way I could do that is I could define my work center using something called a transfer node, which we've seen before. Node, and let's say 3, if I'm doing this in for the assemble station, 3 server-based objects. Right, so I take that concept of finish and I say, okay, let's put a transfer node out front. And then from all of those assemble stations, I'm just going to go to the transfer node. And then in the transfer node, I will use a select from list option. Because again, I know this. I've seen this in Simio. Right, so I'm going to use this select from list. Okay, so now what I'm thinking is I have this concept of a work center, which starts out with a transfer node. And I have, however many stations I have one of these server-based objects. And so that whole thing is what I'm going to call a work center. Okay? And now I'm thinking in my head, again, I'm striving for a data-driven, data-generated model. So what I'm seeing is a resources table that has a transfer node and 3 server-type-based objects. It's going to be this work center. Okay? Does that make sense? Now, at this point, we still don't open Simio and say, hey, how can I make that work? We're still at the implementation stage, and we're just looking at these basic constructs of what we're going to do. Okay, so I'm satisfied with that basic structure. And then I look at these guys, and I say, well, every one of them has setup, process, finish. So I'm going to use task sequences. For my task sequences, I have material consumption and things like that. I know, I'm in the back of my mind, I know all these things are going to happen, but I also know task sequences support all those things, secondary resources, material consumption, right? And so I'm not planning exactly how to do it. I'm just conceptualizing that, hey, this should work. Okay? Does that make sense? Any questions for me about that basic process? Okay, so at this point, I'm satisfied with my work center. I've defined my work center. I take this sheet of paper. I set it aside, and I keep it because I'm going to come back to it. And as I promised, here are all mine from when I did this problem last week. Here they all are, doing exactly what we're doing. Okay, except when I did it last week, it was for the first time, and now I'm just kind of replicating that. The next thing that I'm interested in is the bill of materials, right? Bill of materials. Okay, so let's just take one of these modules. And so we have module A, and it had comp A, one of these. Yeah, had one of these. Comp B, 2 of these. Comp C, 4 of these. All right, so when I think about the module itself, this is what it has. Okay? And so now I'm thinking back to one of the other models that we did, right? So one of the other models we did, I have it up here, this constraint element model that we did, right? And if you remember this one, we had defined part A, part B, raw material. I knew I would do that. Should be auto switching. Do what I want. So we defined material, part A, part B, raw 1, raw 2, raw 3, raw 4. And so we defined this bill of materials. All right, so if you look at part A here, we used the bill of materials definition and said, hey, that takes 1 raw 1 and 2 raw 2s. Okay, so we define that bill of materials within the material element. And then corresponding to that, we have a task sequence here. And in my task sequence, right here in setup, voila, I have that bill of materials. Okay? Does that make sense? So I'm thinking about that, and then I go back and I say, okay, I've seen this before. But when I look at the problem at hand, it's not really going to work that way, right? Well, why is it not going to work that way? Well, what about the other materials, the paint and the box? Right? So this is just for the component, for the kit. When you get to paint, when you get to the finish, you're going to consume some paint. Okay? So maybe I say, well, what if I just add paint here? Paint. Put an asterisk there because we know the paint color matters. We'll come back to that. And so this whole come back to that is an important thing when you're doing this type of methodology, because you can go down the rabbit hole saying, wait a second, I've got a whole bunch of different kinds of paint. I need to specify. You need to put that out of your mind in the short term and just say, okay, I know I have a paint consumption. I'll deal with that, which type of paint later. And then we also know we have box A, for that, right? So that's the complete bill of materials for component A, or I'm sorry, for module A. Well, this still isn't going to work using the mechanism that we had in the constraint, right? Because when I get to kit, I don't need the paint, and I don't need the box. I just need the first three. And then when I get to finish, I don't need the components, and I don't need the box. I just need the paint. Right, so this general notion of defining the bill of materials with respect to inside the material is not going to work. Okay? That makes sense? So we need a different way. Okay, so we go back and we say, well, what about this one where we used a table? All right, so if you remember this, in the fourth one where I used the bill of materials table, I said, well, what if we define the bill of materials within a table? So now, you guys got to remind me when I haven't done that. When I said I couldn't use this thing, that's what I can't do, is I can't ever remember to switch back and forth. Okay, so let's define the bill of materials in the table. So now we have a related table. So I have my parts table, I have my bill of materials table, but it gives me that exact same information that we saw when we defined it in the material. But the key here is that it's not defined in the material. Right? So if I go look at my materials here, part A doesn't have a bill of materials. Part B, no bill of materials. That's all done through this table structure. Okay? So we're making a little progress here. Right? So one thing I can do here is I go back to my DocCam and say, well, how did we do this for the previous model? Right? For the previous model. Well, we had parts. I'm just going to name this materials because I know I'm going to do that for the coming model. Right? And I had the primary key called mname. And so in my notation, when I have that little box, the little line, that means it's the primary key. If I don't have the lines, there's no primary key. So I don't have to write PK all the time. Okay, and then I had my bill of materials table. Put it right here, BOM. And this had mname as a foreign key. And then a component material. And something like that in the ER diagram notation, right? So I have my materials, mname, and then I have a foreign key in the bill of materials table, and my component material, then I also have quantity here, right? Okay? That's what's implemented in that other model. You guys with me? So I could do that, right? I could have all my materials, component A, component B times 2, component C times 4, paint box. Still doesn't solve my problem, right? Because what I've really done is I've taken the bill of materials out of the material, just put it in a table, but I still have the same problem where I have all the materials. Okay, so I have to go back and remember, well, in this problem, it's a little bit different because this problem I also have a task sequence. Or not a task sequence, I'm saying I have a part sequence. Okay, and so if we go back and look at one of the other models that we did, I remembered it this time. Case study 2. Right, so here's our part, right, and then here's our sequence. And so we had the sequence list attached to the part. So when I said, what's the sequence for a part, I can go to my part thing here, and there's my sequence. And it says, what's the sequence of operations on this part? Okay? I have the same situation here, right? Because I've got to go to kit, to assemble, to finish, to package. Right? So go back to my thing and say, well, I know I'm going to have something that looks like this. I call it routing in the implementation, so I'll call it that here. Right, and how the routing worked in case study 2 is that I have my material name, mname. It's a foreign key. I have the node or the destination and some other information like the processing time and all of that kind of stuff. Okay, and then this is a foreign key there. Right, so when I look at that, when I expand the materials, then I can see the routing, which is what we just saw. Well, we're going to see this again. Right, we're going to see this here because I go from kit, kit, assemble, finish, package. So I'm going to have 4 of those. Okay, so I have these 2 things. So the key that I have to figure out is I need to somehow connect this to this because this doesn't work. That doesn't work. But if I go in here and say, well, let's define a primary key here, routing key, that's my primary key there. And then I add a foreign key here, get rid of that. We don't need that. Routing key, foreign key, like that. Now we're making progress, right? Because now even though I have all of my materials listed in the bill of materials table, it's going to be tied to the routing rather than tied to the material. Okay, and so what we will see is in our, for example, if we look at component A, we're going to see component A, module A, module A, and then module A has a routing, and the routing is going to be kit, assemble, finish, package. And then I have BOM, comp A, comp B times 2, comp C times 4, nothing in assemble, paint with our asterisk, box C, box A, sorry, box A. So that's exactly what I need, right? So if I implement this basic structure, this looks optimistic, right? Because we know that we've already done the table-based structure when it's tied to the part. We know that we can relate it to the sequence because we've done that with the sequence. So the key insight here is that I just need to tie the bill of materials to the routing table rather than the materials table. Okay? Make sense? And so at this point I'm looking, and let's see, go back to my laptop. And I'm confident with the materials element, raw materials. I've already looked up in Simio how to do Simio help how to do this. I'm confident with that. I'm confident with work centers and stations. This bill of materials consumption, probably the most complex thing that we've seen here. But again, we have a strategy. Okay, we don't know exactly how to do it if you've never done it before, but we have a strategy. Okay? But we still haven't opened Simio yet other than to look in the help. Last thing is, let's look at the data table structure. Right? So we've already laid out part of it here. I've already laid out part of it right here. Okay? But I'm going to do the whole one, but instead of making you watch me do it, which will be incredibly boring, put the finished product here, and you can see the one that we just did is right here. The one we just did, is the little component that we did is right here. Okay, and so I added the orders, and I added the resources, and I added some of the links. Okay, and so let me give you an indication of the notation here. And again, if you looked in my handwritten notes when I did this, this exact thing is there. You couldn't read it because you can't read my writing and you can't read my scribbles, but it's there. I promise you it's there. Okay? As I said, this line here represents the primary key. If there is no line, then there is no primary key, like the bill of materials up there has no primary key. It just has a foreign key. The solid lines is a key column foreign key relationship. The dash lines take a little bit of explanation. Okay, the dash lines, if we look at the dash lines, let's look at the materials one first, right? Its material has a dash back to color. Because remember, we're going to paint the color, we're going to paint it either red, green, blue, or yellow. Okay, so we have an element representing each one of those colors of paint. So I'm going to have an element for red paint, an element for blue paint, an element for yellow paint, an element for red paint. Okay? The color, though, has to be a list element. The reason I know it has to be a list element is because I went and looked at Simio help for the sequence-dependent changeover, and I say, hey, how do you trigger these sequence-dependent changeovers? In other words, how does Simio know what color to use? Well, it creates a list, and it's all based on a list. Okay, so what I have is a material, red paint, blue paint, yellow paint, blue paint, but in the materials table, it's a material element. And in the orders table, it's a list. But the list represents the element. So it's a dash line because it's not the same data type, but it represents the same thing. Okay? And we see the same thing here between my routing. Because remember when we do routing, if we do a sequence, then we have to have a sequence destination. Remember when we set up a part sequence, remember we have a sequence table? And what makes a table a sequence table? If it has a column with a type sequence destination. Okay? So sequence destination is the type here. But back in my resources table, when I say like kit or a symbol, right? It's an object. It's not a sequence destination, it's an object. Okay, but they represent conceptually the exact same thing. So it's a dash line because that's the conceptual relationship, but it's not the same. Okay? Now, once again, this is not a linear process. So almost certainly when I first implemented this, I said, well, I'm going to make color a foreign key on materials and then start working on it and say, wait, that's not going to work. So then you go back, and that's why you write it all down, is because you're going to go back and forth. You know, I can guarantee that, well, I shouldn't guarantee, but I will. No one here is going to write down the list of things and then perfectly execute it in one fell swoop. Okay? So you write it down, you go back, you work with it, and so on. Okay, now at this point, this is where I would say, okay, let's look at implementing some of this. Okay, so I know how to do all of the standard stuff. Right, go back to my list here. I know how to do number 2, all my standard stuff, source objects, creating, server-based object, blah, 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 auto-create. I know how to do all that, right, because I've done it 100 times. My new things, we've just laid out exactly how, well, we've laid out a plan for doing all of our new things. I don't know if it's going to work, but we laid it out. And we have our table structure, right? And so now I would say, okay, let's go look at trying to implement this. Okay? And that's what I do in the video module. Just pick up from here and say, okay, now let's make this all happen. Okay? So, again, keep in mind, and I mentioned this in the video too, what I just laid out here for you in about 25 minutes probably took me 3 or 4 hours to do. So it's not like I just sit there and write all this stuff down. It's a process. So I don't want to give you the impression that you should. And the reason I say that is because I have people all the time say, you know, I can't figure out what to do. And I'm saying, well, that's the plan. You've got to think about it. You've got to work with it. And it just doesn't come out as a linear thing unless it's a trivially easy model. Right? And so I worked on this for several hours, I would say, in the conceptual design stage. And then as you'll see in the video, I don't remember how long the video module is, 75, 80 minutes. But it was longer than that for me to actually do all of the work to put it together. So when you look at the video module and you say, why can't I do this in 80 minutes? You're not supposed to be able to do it in 80 minutes. It's supposed to take you a little bit longer. But the goal of the video module is to step you through the exact sequence, right, of things that you've probably never seen and give you a pointer on how to do that. Okay, and now what I hope to happen, depending on feedback and how we stand, we're going to modify this for case study 4. And case study 5, I'm going to give you something totally new you've never seen or anything, and just say go. So you'll get the opportunity to do it from scratch with not me saying, here's what you do next, here's what you do next, here's what you do next. Okay? Any questions for me? Okay, so again, let me re-emphasize this. Let me re-emphasize right here, go back here. Back here. We have a test next week. We have spring break after that. Here. There's plenty of time to do case study 3, but you are going to have to plan. You are going to have to sit down and say, okay, I want to study for the test during this time. I want to do case study 3 for this time, and so on. You're going to have to plan it. There's plenty of time, but you do need to plan. The timing is not the greatest in the world with spring break, but it is what it is. Okay? All right, I will put a discussion forum up for test. If you don't see it by tonight, someone remind me, because that means I forgot. Okay? All right, see you guys.
By the way, Grant already.
What was the problem?
When in the table.